Good afternoon and welcome to our session on behalf of the Mathematical Association of Victoria. I'm really pleased to have you all here. Today, we're running a session on STEM and mathematics, a career that makes a difference. I will be your host, Peter Saffin, the CEO of the Mathematical Association of Victoria, or MAV. And we'll be joined today by Professor Asha Rao, Associate Dean of the Mathematical Sciences School of Science at RMIT University. I'm very pleased to have Asha with us today. She's passionate about mathematics, she's passionate about STEM careers, and herself being a mathematician is well placed to speak about it with all of you today. I'll hand over to Asha soon. I just wanted to introduce you to some of the things that the Mathematical Association of Victoria does, especially relevant to some of you as students. This diagram shows a whole bunch of things that we deliver, but for you as students, check out the green circle on the bottom right, and you'll see there are a number of other student activities that you may be able to be involved in. We may have some teachers with us today as well. Please note that all of these activities are usually booked on behalf of students through schools. So if you as students are interested in any of these activities, please get in touch with your teachers after checking out our website and seeing what may be of interest. Now I'll hand over to Asha, who will speak to us and run us through her initial talk, and then we'll move into some questions. During the session as well, if you have any questions, pop them in the chat. I'll keep an eye on it, and we can ask them as we go if we need to. I'm really looking forward to this. Over to you, Asha.
So I'm going to start with a little bit about myself, my own journey, how I got to where I am, not in any detail, but just to show you all what is possible with mathematics. And then I'll talk about where it can take you. So you can see from what I have done, I can also show you what you could do. So before I start, let me acknowledge country. I acknowledge the people of the Woiwurrung and Boonwurrung language groups of the Eastern Kulin Nation on whose unceded lands I live, and as an RMIT employee, I conduct the business of the university. I respectfully acknowledge their ancestors and elders past and present. I also acknowledge the traditional custodians and the ancestors of the lands and waters across Australia where we conduct our business. So what RMIT is very sort of committed to reconciliation. So one of the things we are encouraged to do is to do acknowledgement of country. And what I have done to personalize this is I use photographs that I have taken, usually of the evening sky or of the night sky. So this picture is something I took on the 28th of April at about 5 a.m., I think, or maybe a little bit later, of the 4 planets in a row. And there was, I tried it a little bit earlier, and there was the moon as well, but unfortunately it was too dark. It's crazy for the camera, and this is where mathematics comes in. For the camera to be able to actually capture this picture, I had to wait till about 6 o'clock, till the first light was there to be able to capture. As you can see, all 4 planets from memory, I think it was Jupiter. Jupiter is the third one. There was Mars, Venus, Jupiter, and Saturn. I can't remember the order anymore. But that was the crazy thing. I was up at 5. I could see it. It was just beautiful, but I could take no photograph. It was just totally too dark. And then, so I waited till about, close to 6 a.m. And I got this beautiful photograph on that day. It was crazy. It was not too cold. 28th of April, much better than currently. So what am I? So I decided to do a bit of a word cloud to show you what I do, all the things I do. So I am a mathematician, as I said, and I am a professor of mathematics. I'm also an associate dean, which basically is head of mathematics, the head of the department. But I do a whole bunch of other things. Like, for example, I'm a team leader. I do gender equity. Most of my research is in the area of cybersecurity. And all of you all will have encountered algebra. So my PhD is in algebra. I must say, I love mathematics, and among all of mathematics, I love algebra. Because what it does is it stops us having to think of exact things. It allows us to replace numbers, for example, with ABCDs and things like that, and try to generalize things. So something that can be used across a number of different applications. I am a superstar of STEM. So as a 2019-2020, I put in an application and I was selected as one of them. So my aim when you become a superstar of STEM, you have to decide what is it that you want to do. So my aim then was to actually talk to school students and to teachers about mathematics, about how wonderful it was, how beautiful it is. So if you go into the garden, for example, have you noticed the leaves on a stem? They're either parallel, opposite each other, or they're in a whirl. They go up in a spiral. Those little things, it's so much joy to watch it. I'm the sort of person when I'm sitting in a bus or, I will be counting the lampposts. Why? Don't ask me. I have no clue. I just count. I count steps. I count lampposts. I count people. I'll count whatever is around if I have nothing else to occupy my brain at that point. So this is all I am. So I am from India, and the WIMSIG, I was chair of WIMSIG. So WIMSIG is a Women in Math Special Interest Group. So I have worked, so crazily enough, I have worked in tracking of money laundering. And now I don't know how to actually launder money. I have worked on how to track it. And this has resulted me coming to the notice of the United Nations Office of Drugs and Crime. And I have been invited to observe, because I'm not a nation state, so it's only nation states who are members. So I've been, and they can only actually join meetings. So I've been asked to observe meetings on cybercrime. So when they talk about how to reduce cybercrime. So cybercrime, like much of what we do, like the fact that all of you all are here and not in my house or at the university, what it says is that we can reach out, but when we reach out, people can also reach in. And not everybody who reaches in has good intentions. So cybercrime is when the people who reach in don't have good intentions. So I've done a lot of things. So if you look at the research that I do, I'm trying to see if I can see more. But anyway, the research that I do, so focusing just on that, you can see my PhD was in something called Baire-Star rings. So Baire-Star rings it's the algebra which sits behind X-ray crystallography. So how do the molecules and how do the atoms interact with each other, not necessarily from a chemical sense, but more from the sense of how they sit and how they behave when, for example, you have that electric pulse or anything that goes through. So that was my original research, starting with my PhD. But I did my PhD in India. And so when I came here, I had to change because I didn't have people, working in that area. So I did what is called Hadamard matrices. So Hadamard matrices, which then led me into error correcting codes. So what are Hadamard matrices? When you send signals, for example, when we are talking, it's not my voice which is coming across to you, it's signals which are coming, just electrical signals. And one of the best ways, or the earliest ways of transmitting those signals are what are called the Walsh-Hadamard transforms. So they transform voice into signal, and then they untransform it, if you think of it like that, at the other end. So that is what are called error correcting codes. So then I went into, from there, we went into, cryptography, went into cybersecurity, and now I'm working in what is called the security of the Internet of Things. And there's a lovely example somebody talked about the other day, is that they bought a new heater, water heater. And as you all know, most of the water heaters, almost all water heaters sit outside the house, not in the house. So this one was sitting next to the neighbors, next to the fence. And the crazily enough, the hot water heater came with Bluetooth and a password. But who could see that password? Only the neighbors. The people who actually owned the water heater couldn't couldn't see the password because of how it had been set. So those are the things that we need to think about when we think about cybersecurity. So little things like that. Where is the password actually positioned? And that has got to do with mathematics. Remember, that is the spatial side of things. It's a box. And where you sit it depends on the spatial thinking that you have, the mathematical thinking. So I do things like, and part of that I've done networks, collaboration, and social network analysis of how social media works. That's also some of the research I'm doing. I'm looking at intrusion detection. How do you detect that somebody has gotten into a system? And finally, some of the things I'm doing right now is what is called control theory. How do you control, for example, unmanned aerial vehicles? So that is coming from left field. It's just something that I've started doing. It's very interesting. So some of the most recent work that I've done with my postdoc is looking at how do you control robotic arms in space robots. So when you're trying to do, for example, fueling, painting of the International Space Station, for example, you have to control that arm. And most of the research is done where the arm is rigid. There is no movement. But our arm, as you know, has got a flexible joint here. It's got a flexible joint here. So you have to work out how do you get a space robot arm to move with that flexible joint. And that's the work. And that's called control theory, controlling the motion from different angles. So what I can say to you, and something that you are just basically about to start on your journey. You just started on that journey. So enjoy that journey. But one of the things you remember is life's journey is like a river. It is not from A to B. It's not a straight line. It's not linear. It's not parabolic, hyperbolic, or any of those things. It is like a river. So what happens, as you can see, the river has come around here and said, oh, I can't go anywhere. This may actually be a slight hill or something. So what it does, it goes back and goes another way. And that is how we have to go with life. So think of this as there is a problem here. I can't surmount it. So what do? I find another way to go around it. I find a solution. And that is what life is about. It's not about always having it easy. It's, as a matter of fact, I would say from the way my own life has been and the way I have looked at it, I love challenges. And I'm asked now to speak to first-year undergraduate students. We're trying to show them, especially if they have not done, for example, math methods, which is the higher level of maths. We're trying to tell them that, mathematics is fun. So the way I put it is that the reason I love mathematics is when I solve a problem, the high I get, I can't get from drugs. And the funny thing is, a student actually asked in the feedback, say, has she tried all drugs? And my response to that was, I don't need to. I have mathematics. That gives me all the highs I need. Why do I want to try the drugs? I just try a harder problem. And that is it. Somebody else said the other day that mathematics is a struggle for everybody. For every single one of us, whether you're a school student or you are at my level as a professor, it's a struggle. But you know why we do maths? Is because we love that struggle. We love it when that struggle and, we struggle and it opens out. And that's what life is. When you work hard and you get a solution, you get something, the joy that you get is totally different. If you just got it just because you asked for it, where's the joy in that? And when you think about it, some of the things I say is, I remember, one of the people always say to me, oh, you must find maths easy. And at one point, I think in year 9 or something, I believed that myself. I believed that. And then in a test, everybody got 8 and 9 out of 10, and I got 6. I never did that again. So I look back and I think, and people say, you found it easy. I said, no, I did every single problem in the textbook 3 times. I had a textbook. That's all I had. And I did every single problem 3 times. 1 when the teacher said it, 2 when I was revising, and 3 just before the exam. Why? Because I wanted to understand different ways in which I could do it. I wanted to understand how I could do it deeper. And the only way you can conquer the little mistakes you make is by repetition. That's how a piano player becomes an international. player. That's how the best footy players do it. That's how, Novak Djokovic, for all the fact that you may or may not like him for his attitude, he practices and practices and practices. And that's exactly what maths is. You have to practice. So why would you want to? I'm coming to this thing. Why do STEM? Why do maths? So STEM, science, technology, engineering, and holding all of that up is the M, the mathematics. So why are you more interested in STEM? Why should you do mathematics? So I have actually got some facts and figures. And over the last sort of 5-6 years, things have really been ramping up. Maths has often been hidden, but now it's coming out of its shell. And the best thing we learned was from COVID itself. Words or phrases like flattening the curve, the 7-day average, the R0, the RF, the way the virus spreads, how many people does it go from one person to the other? How many can it infect? All of that is mathematics, is statistics. So here, as it says here, the US Department of Commerce, Economics and Statistics said that in the last 10 years, STEM jobs grew by 24%. While non-STEM jobs grew by just 4%. This is by the Office of the Chief Economist, STEM jobs 2017 update. So that's 2017. Okay, so how's it been going? The World Economic Forum Future of Jobs in 2020. So this is a survey that they do to ask the biggest companies around, or even the small companies, what are you looking for in hires, in future jobs? Where do you think this is going? And what they have said is that the skills gap in the local labor market is the perceived barrier to adoption of new technologies. To be able to adopt new technologies, we need to be able to work out how does it fit in. And to be able to work out how to fit in, we need mathematics, we need STEM as a whole. We need people who are able to do it. And also what the business leaders are saying are they're consistently citing difficulties finding graduates and candidates with the required maths and stats expertise when hiring for data analytics. So when they want to hire a data analyst, there are when you go out, there are business data analysts, there are data scientists who are more programming side. But what you need is the mathematics and statistics to understand how to make a huge difference. So just being programming is not enough. To be able to understand what comes out at the other end, and that is what mathematics gives you, that intuitive feeling. And let me tell you, of all the things that I have been teaching, the mathematics that I have learned and that is inside me often provides that intuition, allows me to think, okay, so this is what I want. This may not happen. What am I going to do next? Okay. And also, how do I change this thing here to get that thing to change? Little things change big things. So that is how, and it's a little mathematics. You may or may not have heard of quadratic equations yet, second order polynomials. Some of my research, when I go, it's looking at high level things like how do I do storage of data in such a way that you can pull data out very quickly. You know what it comes down to? It comes down to a quadratic equation. It's trying. So what is the research? Coming up with the quadratic equation. And there's also something called Taylor's polynomials, which we learn, in first year undergraduate. It's the first things you learn. It's the mathematics behind compound interest. It's the mathematics which tell you if you put a little bit of money every month, every week into a bank account, which gives you interest, it will rise in this manner. It won't go exactly straight, but it will do that, but it'll keep rising. And that's what compound interest is. And that's the crazy thing. It's all of it is mathematics. It's simplified, but it's mathematics. So one of the things that is known is that 75% of the fastest growing jobs will require STEM skills into the future. So it is what they say. If you look at this, Cassie Pennycook she says, I am more than a number. So mathematics is much more than number. It's keeping communities safe. So that is what she does. She's a program manager for the CFA, for the country fire authority. She runs the project management office for CFA's Service Delivery Directorate. So this is how, to be able to manage fire. So in my own department, there are people who work with how do we manage fires. The fascinating thing is right now I'm sitting with a project for third-year students. And they are working with a company in California, a startup in California. So what does this startup do? It has got sprinklers. You remember, unlike Australia, California, because it sits on the San Andreas Fault, it is very prone to earthquakes. So all the houses are made only of wood. So all of these houses have got sprinklers systems in them. And what this company does is it is trying to work out how to make those sprinklers smart, in the sense, when should it be turned on? What wind direction? What wind speed? What is the temperature? What is the humidity? How far is a fire? All of those things it is trying to. And the people who are helping them with that is my third year Bachelor of Mathematics students. They are working out how to do this. So why mathematics? Why study maths and stats in particular? One is, of course, if you want to go into, for example, engineering or anything for that matter, the way of thinking, the logical thinking that you need for mathematics will help you in every field. Often I say to students will tell me, I don't need to do higher maths for this. Do the highest math you can, because it will give you, in many ways, an unfair advantage. It will help you grow faster, to learn faster. And so, if you look at maths and stats itself as a degree, as a career, what it says, the 2017 IBM report said the number of maths and stats focused data science and analyst positions, so this is maths and stats focused, and data science analyst will exceed 2.7 million by 2020. So remember, there are people who are retiring as well. So these are new jobs. The US Bureau of Labor Statistics 2020-2030 job outlook says there is a 33% growth in jobs for mathematicians and statisticians. Career Cast puts statistics and mathematicians as the best job with median salary of US dollars 98,000 a year. And these are sort of the things. So it says mathematicians, statisticians, and data science with the know-how to interpret data are in ever-growing demand. And this is something I see myself. Over the last 6 months, I have lost 4 staff because industry has picked them up. They have gone into industry. Industry needs them, and they are able to command higher salaries. So I'm trying to get new people, constantly trying to get new people. So what can you be if you do mathematics? You can be a risk analyst. What does she do? She wanted to be many things: an artist, a tennis player, a lawyer, a graphic designer, an architect. To be honest, I never really knew what I wanted to do. That's why I love working with startups. From planning and forecasting to analytics and operations, research management and insurance and everything in between, I am the go-to numbers person. That is Solya Vellappan, who is a startup consultant. And then you have Piera Belanca, who's an architect. She says, I grew up surrounded by beautiful buildings. Architecture was the obvious path for me. As I've grown older, I've fallen in love with heritage restoration, which brings new life to iconic buildings around the world. There's beauty in the maths and geometry that informs architecture. So let me just tell you one thing. You may have heard of the Sagrada Familia, Gaudi's masterpiece in Barcelona. And when I went there, I was just so amazed, because one of the things we teach first-year mathematics, engineering math students, is about different types of structures, things like hyperbolic paraboloids. Hyperbolic paraboloids, these are strange surfaces that you can form. You know what? Gaudi back then used his imagination, and he used those structures to actually build into the Sagrada Familia. It is still being constructed, hasn't been finished yet. But that's the amazing thing, high-level mathematics. So one of the things I'm also interested in is gender equity. As you know, we have a pay gap. And there is a White House report which says that women who do STEM will earn 35% more over their lifetime than women who don't work in STEM. So do the mathematics, because that will allow you to do the STEM. And by doing the mathematics, it gives you more options. So always do more than you have to. Enjoy the process. It is a struggle. I always say diving has a degree of difficulty. Similarly, maths should have a degree of difficulty. It is difficult. I'm not saying it is easy, but it is worth every minute you spend on it. It's absolutely worth. So some of the work that I've been doing is trying to get girls more interested in maths, because how are we going to close that gender pay gap? It's by girls doing more maths and consequently getting better paying jobs. And finally, as Cat Phillips says, you may have heard of Cat Phillips. She says, I choose maths to supply power and gas to your home. So I'll stop there if you have any questions.
Thanks, Asha. If anybody wants to pop any questions into the chat, please do. I've put a few links into the chat as well for you to link to some of the things that have been mentioned today, like the STEM Superstars of STEM and the careers. AMSI have a careers in STEM booklet, which collates up job advertisements from various places. They give you an idea of the types of jobs across the STEM industries and in mathematics that are really relevant for you. And that's a great place to start to get an idea. But I think that we know that even the starting salaries in STEM and mathematics careers are generally quite high compared to some other areas. And, you know, it's a great place to progress. And as Asha has pointed out, with so many opportunities and choices and expansion of the STEM industries, and Australia being a bit of a research hub and an innovation hub as well, there is going to be a ton of career opportunities that will allow you lots of choice in future.
Yes, and something that another statistic that I did not say is that between 2018 and 2021, the number of graduates who maths and stats graduates who are getting jobs has risen from 75.6 to 91.9. It's really ramping up. At this point, with everything that's happening, we need mathematics to be able to answer the big questions. How do we deal with climate change? How do we do more sustainable? How do we clean the oceans? All of that needs maths and stats.
It does. And I liked your comments about doing the most challenging maths that you can. One of the things that we've seen and heard stories about is that students are sometimes choosing to do no mathematics or a lower mathematics and going into a university course that requires a significant amount of mathematics. And there's an example of a nursing course where something like 45% of first year students were failing the mathematics in nursing. And that's a career where we don't really want people delivering dosages of medicines that are incorrect. And so the students themselves are disadvantaged by not choosing to do a mathematics. So one of the things to consider as you do your subject choices is the balance between ATAR and setting yourself up for success in your career in university after year 12. The more or the higher level maths that you do, the easier some aspects of your university courses will be. Would you like to comment on that, Ash?
Yes, absolutely. And I'm just thinking, you know, ATAR and year 12 is so important. But you know, the funny thing, in 3 years' time, when you do your degree, it won't be that important anymore. It'll be what you do in your degree, which is much more important. It's how I don't want to say the word successful, how comfortable you are with what you're doing. Because, you know, if you're going to struggle with the mathematics, you don't have time to learn, you know, how things fit together. So to learn how things fit together, you need to be comfortable with the mathematics.
That's right. So I've got a question here in the chat: how to encourage Year 9 to 10 students or kids to do mathematics. So that's an interesting one, because there's two sides to that, and possibly that's a question coming from a parent here tonight about how parents can support that. The other side is how can schools support that, which is a complicated question I could talk for hours about and may not have a direct answer to.
Yes. So what I say is, one of the things I heard just the other day, somebody said, do maths at meal times. This is for the little kids, of course. The most important thing is to be enthusiastic. How do you get people to do maths? By being enthusiastic about it yourself. So for a parent, don't ever say, I'm no good at maths. It's just because you have not done it. Don't say, I was never good at maths. I find it difficult. No, everybody finds it difficult. But you can do it. And that is how to, this is what I say to teachers as well. Be passionate about things, and to the students as well. Fake it till you make it. That's how most of the people, when if you look at the great actors, they faked it until they realized, hey, I can actually do this. And that's the same. It won't come the first time. As they say, what is that famous thing? It won't happen overnight, but it will happen. So always do challenge yourself. I remember when I was in the second year of my master's, there was the toughest subject, which is called real and complex analysis. Out of 125 students, only 3 of us were doing it, and everybody else was doing something else. So I went to my algebra lecturer, because I trusted him more and was able to speak to him. I went to him and I said, you know what? Everybody else is doing that course. Should I do that? And he said, no. Some of the mathematics has to be learned from somebody. And this is the one mathematics you need to learn from somebody. There is maths which you can learn yourself, and there is maths which you cannot learn yourself. And for that, I say, when you are picking courses, pick something you can't learn by yourself. Pick something that somebody will teach you, because there is nothing better than being able to do the harder maths.
Thank you. I'm pointing you towards a couple of resources in the chat too that you might be able to use in future. The first is that we have some careers in maths and STEM activities that we recently released, which for anyone here who is a teacher or even for the students to look through those, and there's lots of information about careers. They're focused around the various areas like finance and space science and biomedicine. And I think once you start looking around at the diversity of careers that come under the mathematics and STEM area, it is enormous. We often think about the traditional careers like engineering, but there's something like over 150 types of engineers, all of which require mathematical skill and other STEM knowledge. Perhaps Ash, you could comment more on the variety that you've seen that these sort of career areas can lead to.
Oh, absolutely. So even at RMIT, we started a space science degree just last year. And it's not just, and I remember years ago, I was talking to someone and I said, so what do you do? And they said, oh, I'm doing fashion design. That's his degree. It wasn't fashion design. So what are you doing now? He was actually designing the fabric on aircraft seats. You wouldn't think that, and that takes mathematics to design the material which goes on a fireman's suit. There has been huge changes. How do you get a fireman's suit? How do you get fabric that can actually talk and realize that the atmosphere is changing, that the weather is changing, the heat is changing, and then come up with new qualities? All of that is in, and if you have STEM, those careers become open to you.
Yeah. There's some really interesting examples. A good one that I've heard before is that seatbelts were originally designed for the average male, not female. Yes. And until it was, you might know, but it might have been in the 1980s when they finally set the standards to actually protect females in cars. So females in cars were something like 80% more likely to be injured in an accident for many, many years. And a lot of the products that are around and the solutions and innovations that we need are actually designed to help us, our society and our environment. And it's not purely mathematics for mathematics' sake, but it is for the betterment of our society and to create equality and opportunity for all people.
Yes, and even now, one of the things that I was reading this book by Cordelia Fine about data and how it hides stuff. You know, heart attacks. Most of the research has been done on men, and men have certain characteristics which point to a heart attack. Women don't have those. So often what happens is when you think about it, you know, the general idea is that more men die from heart attacks, but actually more young women die from heart attacks because they show different symptoms. And because there hasn't been enough research, it means that those symptoms are not recognized as heart attack. And they go home, they're told, oh, go home. It's nothing, no big deal. They go home, they have a major heart attack and they die. So the whole thing is the more women come into these fields, the more we will be able to see what is different. And this is something that you know, reading these books itself awakened stuff in me. And we're doing, one of my PhD students is looking at how do you get small enterprises with less than 9 employees to be more cyber secure. And I realized that we were not collecting demographic data, in which when what would happen is we would possibly get data, which again was all men talking to us. So that is the thing. And that is where we need more change. We need more equity, because the more of us who are there, and you know, I read the book and I thought, oh, wait, hang on. So I pulled it back and I said, all right, we can't send this out. It's only going out now. It stopped it for about 6 months because we had to go back and redesign and decide how are we going to address this question? How are we going to get data so that we could then solve the problem?
Right. Because yeah, it's the challenges that and the joy, as you mentioned, in solving the problems. Once you're applying the mathematics rather than solving a problem from a textbook, then the joy comes in seeing the impacts that you can actually have out there. There's a question here about from Nick about pathways and getting into engineering when perhaps a student isn't quite capable of doing the higher level maths. And I'll answer that first, and Asha might add something, but there are various pathways these days, and you don't need to have a super high ATAR or super high maths to get in to a direction that you'd like to go. And there are so many engineering courses, and universities have different approaches. It may be that, for example, some universities will have a bridging course in mathematics to catch people up to the level they need to be. Or it may be that some universities have more practical approaches to hands-on learning and working with industry that can get you into an engineering type of course that may be more around design and CAD design, which is computer-aided design, or other areas that are related to engineering, from which you can then retrain to become a fully fledged engineer at some point. So I think, as the comment in the chat says, doing the highest level of maths that the student is possible at the time is the right choice. And then finding the right way in and the right pathways to progress to the job that they want to do may take a little bit longer, but there's always various pathways these days. And, you know, students who don't finish year 12 can go to TAFE and end up as engineers if they find the right pathway. So keep plugging away at it and understanding where you want to go and looking for those opportunities that can help. And I would say that careers advisors in schools generally are able to talk to you a lot more about those sorts of opportunities. Asha, anything to add?
Absolutely. I know that at RMIT we have, and the maths discipline itself, the maths department does it. We run 2 courses for engineering. One is for those who have done the math methods, and one is for those that haven't done the math methods. So they have to do the first one, which is called Introduction to Engineering Maths, and then they will actually do engineering maths the next semester.
Yeah. So there you go, off to RMIT. And there's another question.
There's associate diplomas as well. It's like that river that I talked about. Find a pathway. There is a path. You just have to find it.
And much more flexible pathways than there used to be. So we're lucky in that sense with our kids coming up at this age. There's also a question about should we be doing STEM in primary schools? Because we need to make kids more curious and engaged in mathematics earlier and make it fun for them.
But you know what? You're probably doing STEM in primary school. That's the amazing thing. All of you are doing. So STEM is not something different. STEM is just science, technology, engineering, and mathematics. When you do maths and you introduce a problem, which is not just the mathematics, even if you do things like, you know, I've got 4 apples and 15 bananas, you're still doing STEM. There are no apples and bananas in mathematics. It's the math, it's coming from science, it's coming from food science. And so that is the thing. So don't think of STEM as something separate, something you need to do different. It's just the mindset.
Yeah,
The,
and it's
the
been brought to the
awareness.
fore more recently, and we have seen a lot of primary schools putting in STEM centres and investing in equipment. What we really want to see them is engaging well with that equipment, and you're not using it as a gimmick though, which sometimes happen, and schools have to think really carefully about how they integrate it. And the other part of that comment was around, people associating mathematics as difficult, and you've already commented on the Asher, and we talk a lot about that in my job and with our partners, that we need to be positive about it. It doesn't have to be a bad experience. And also for parents who are here today, what kids are doing in school these days and how they're learning may be quite different to your own experience of maths, and we shouldn't put our experiences and preconceptions on what our students are getting at school. But we do still see students, more students starting to say they don't like maths as they get older into secondary schools. And we do talk with the Department of Education and work on some strategies there around how we get that practice in secondary schools to change, and so that we don't lose the passion for mathematics that kids often do have at primary school, but lose in secondary school. And there are system issues with exams driving teaching practice and getting kids ready for ATARs that don't help make the maths fun and engaging. And so, it's a really difficult problem, and thanks for raising it. We've got a long way to go, but believe me, it's something we are very concerned about and we want to impact over time.
Yes, yes. As I was saying as well, Peter, the little things, point those out. The fact that, stems on plants have leaves attached either opposite each other or as a swirl. Look at the petals of a flower. How many petals are there? They're always odd. And think about, why is it they're always odd? Why don't they have even number of petals?
Yes, and then we have some academics in mathematics who are studying art. So if you have an art interest as well, you can tie it to mathematics. But the other side of it is the mathematics in our everyday lives, not as well as the beauty of mathematics. And financial literacy is a classic example where the complexity of financial products, the payday lenders, the pay now, buy later schemes, that people are ending up in trouble because they don't understand the mathematics and how it will impact them if things don't go well. And being able to read your pay slip or negotiate a salary or understand superannuation, all of those things, the best maths you can do will set you up for everyday life decisions, if you like, in the areas of numeracy that you need to survive out there in our society.
And it's not only that. The other project that another team of my students are doing is with a startup in Michigan, where if we have the student loans here, HECS or HELP or whatever. That's bad. But if you think about the US, it's horrendous. And so what they are trying to do is trying to work out a model where they can lend. And so people don't have to take payday loans. And they can set them up for success. And the math students, my math students are helping them with that. Things like, how do I do that? How do we make it sustainable?
Yeah. The question here sounds like maybe a teacher. If we're a school that doesn't do much STEM, any STEM, where do we start? Perhaps, Tara, that'd be something to email me about. We can have a conversation. I would suspect that it's integrated into a lot of what you do, as Asha said, when you're doing reader. If it's a primary school and you're doing readers, you can buy STEM-based literacy readers. And one of the things we promote is using picture books to help engage kids in the big ideas of mathematics. And so there are lots of ways to start bringing it in without having to rewrite your whole program or what you do. And you don't need specialist coding equipment and computers and iPads to do STEM activities. You can build pretend robot hands out of straws and string. So everyday household activities can get kids actively engaged in STEM-based activities. So if you'd like to follow up with me about that, please do. And we can hook you up with some support and ideas.
And the STEM example that I still remember is of my son in year 5. In grade 5, the teacher set them the task of packaging an egg so that it could be dropped from the second floor and would not break. And of course, me being me, I had to give him a hand with that. And his packaging was so good. And I'll tell you what the packaging was. Very simple. Packaging was so good that the egg broke after they played cricket with it. And it didn't break because the packaging wasn't good. It broke because what was holding the packaging together broke. And it was and all I used was shredded paper. That's all I used, because I knew that shredded paper has the air and the flexibility. So I took the egg and I just wrapped shredded paper around it with sticky tape. And they dropped it. They went higher and higher, dropped it a few different times, I think they played catch with it and it didn't break. And then finally they played cricket with it. And I think the packaging, the sticky tape gave way.
Yep.
And that's STEM. That's STEM. That's what
it.
it is.
That's how you start solving problems. So a couple more questions. This come from a couple of people. What subjects would you do to get into engineering? And another related one, which is, what are the best subjects to keep my options open? Now, a lot of universities have removed some prerequisites for entry, but mathematics and a science together, regardless of which science, give you some of the biggest university entry subject choices that you can do. So having a mathematics in the mix and having a science, keep your options open for choices. Specifically for university, Asha, do you have any?
I think physics or chemistry and mathematics, higher level mathematics, absolutely keeps. And I don't remember right now for medicine what is the thing, but I remember years ago they would prefer you to do maths and physics because they could teach you the biology. So mathematics and physics and chemistry, if you want, maybe information technology, history, and also don't think that HAS, which is humanities and arts and social science, doesn't help you. I do know that I love looking at the history of things, because history tells you, and much of mathematics is, if you think about it, is history. If you think of an equation, it's history of the equation. What has it done? Where is it going? So think of your mindset has to change. And one of the things I do is, Peter was saying about art. I sew almost all of my own clothes. And I have sewn a skirt using what is called hyperbolic geometry. It's high level, higher dimensional, high level mathematics. It doesn't stop you. I think most mathematicians also have that left brain, right brain. They tend to be more artistic as well. Maybe it explains why in the mid 50s and 60s, the maths degrees were all Bachelor of Arts and not Bachelor of Science.
Oh, there you go.
Yeah.
And you're right. And we want mathematicians and problem solvers who can work in industry and talk and communicate together and collaborate, which is how a lot of jobs work these days. And so the social sciences or an art subject alongside your mathematics and sciences can help to get you thinking in different and creative ways.
Yep. I've worked with architects and I've worked with, ethnographers. It's everywhere. It doesn't have to be just maths. It helps you speak it's a language which you can speak, a different language.
Yeah. So I popped in the chat a link to our student activities page because there was a question about how could I find some other activities to extend my mathematics at school. That's a place to start, but there are coding camps in the holidays. There are maths camps and STEM camps offered by various universities and by MAV and by the Australian Association of Maths Teachers as well. So if you Google around, you'll find some opportunities, see if there's anything that aligns to your interest there. And our student activities link I popped in has one of those camps, for example, the National Mathematics Summer School and our own maths camp, which is already full, though this with industry partners in September will be on again next year for regional students. But there are others as well. So you just need to Google around and see if there's something that might interest you. Where else? What else here? There's another question from a teacher from Jimmy. Jimmy, I'd ask you to follow up with me on that one as well so we can keep focusing on our students, and mainly we have here today. And it's another question from a teacher about really, how do we get our students, interested and working hard on making the maths applicable and interesting in class. And, I can share again with some teachers some of the work we've been doing with Department of Ed to write some middle years maths challenges, which are all about getting students engaged around their learning interests, around the things they're interested in, linking it to the mathematics and making it a challenging problem solving task, which you can use alongside your other teaching toolkit, if you like. So there are lots of opportunities. If you can follow up with Mav and get on our newsletter, you'll see a lot of those things, but that's what we're here to support you with as well. So please follow up with me, any of the teachers who'd like more information.
And of course, the AMC has got a lot of resources as well. So
AMSI's great. I popped that link in the chat earlier to AMSI for their Careers in Maths booklet, and they have all of their, some of the pictures that Asha showed were from the AMSI, I don't know what they call them, mentors, superstars.
Superstars. Yeah, I think
Yeah.
so. I don't know. iTunes Maths.
Yeah. And again,
also, they have the calculate.org as well, which has got a lot of maths resources for teaching.
And one thing we have got coming up for you, if you're still here and the students, is our Careers in STEM Day, which is in September. And that actually has speakers from various locations, various industries. And the previous Girls in STEM Day has some videos under the 2018 and 21. And we have architects, we have people from Reserve Bank, we have people from the Bureau of Meteorology, we have someone who works at Cadbury in their marketing department doing data work, right? So the diversity of the careers there's some great examples where these people tell their stories of their careers in STEM. It's just another resource that you can use, and it's just that research that will help find maybe a link for you or something for you that helps you decide what your next step might be.
And this which reminded me just now, Peter, of one of my PhD students who was doing a PhD in architecture, but her bachelor's degree was in engineering.
Right.
She's an electrical engineer who then went down the architecture.
Yep. Yeah. So Engineers Australia, if you Google Engineers Australia as well, you'll get some great information there around the types of careers in engineering, and they are as diverse as you could ever imagine as well. We don't think of engineers anymore as building bridges, and we would like to think of engineers that do as connecting communities, not building bridges. So again, thinking about the social impacts you can have in those careers. And so, Asha, would you like to wrap up with any final statements? We're just right on time.
Just saying, enjoy the mathematics you're doing. Don't think that I can't do it. Think I can't do it yet.
Yes, well said. Great statement to finish on. Yeah. And thank you, anybody. As I mentioned, I'll pop my email in the chat before I go. If anybody wants to follow up with me directly about anything, please do. And I'm very pleased you could all join us tonight. We had a good number of people here and really appreciate your time. And I'd like to thank Asha for her time, her personal time here to support this event and getting the word out around the great careers you may all have in future. Best wishes, and you're welcome to go when you're ready.
Yes, thank you. Thank you. I enjoyed it. I do enjoy talking about maths.
It's a great conversation. Thank you, Asha. I really enjoyed it myself.